Hello, and welcome to my talk, Enabling Applications with Tailored Micro-Optics for Beam Shaping of High-Power Lasers. The Focuslight group consists of several business units: diode laser, laser optics, automotive, optical systems. The laser optics business unit consists of LIMO, with 28 years of micro-optics expertise for development and production of high-quality beam shaping solutions, now paired with an automotive-grade high-volume backend capability in Dongguan. The Focuslight group can deliver the full package, from photon generation to photon control to photonics application solutions. Here at Laser Optics Business Unit, we focus on photon control, which consists of simulation and production of high-quality micro-optics. If we start with the design, we usually begin with the laser source like VCSEL, VCSEL array, nanostack, emitters, DPSSL or alike, and then define the output in simulation, either symmetric or asymmetric. With this, we can define how the surface of our micro-optic should look like, produce it, and then compare it in reality with the simulation. As you can see, simulation and measurement match very well. We can do geometric and wave optics simulations for optimization. This results in design capabilities from single components to lithography homogenizers and integrated systems. Some example products are then collimators, couplers, homogenizers with contrast down to 1.5% or lower, spot, line, field, or multispot generation. How do we do this? Well, we have a unique production method for high precision 2D freeform that produces cylindrical or acylindrical lenses arrays in glass. We have a wafer-based production up to 300 by 300 square millimeter to yield high volume and low cost production. Both wafer size, that's important, can be individually addressed. That means the front surface of the wafer doesn't need to be the same as the back side, and it can be structured perpendicular. This yields the possibility to produce monolithic solutions. So for instance, the top right corner, here on the back side, you see an FAC that collimates a bar. On the back side, it's an SAC array with a superimposed focusing lens. So this one, for example, can couple a mini bar directly into a fiber. We can structure nearly any kind of glass material from UV to mid-infrared, for instance, high-index glasses or fused silica, and we also offer in-house coatings or with our external partners. Some example products would be fast access or slow access collimators, our famous beam transformation system, the BTS, or homogenizers, wide-angle diffusers, or line beam generators. We also offer pre-aligned micro sub-assemblies, and you can choose from our extensive standard portfolio or go for a customized solution. If you choose the customized solution, usually our design starts with the lens shape formula, and as you can see, you're not limited to a single radius. You can have a more complex design, like aspheres or the design as you should see it here in the bottom left corner. It doesn't need to be necessarily symmetric. It can also be asymmetric in design, and you can have any superposition and cross-orientation. So you can have monolithic designs, and together with our assembly, you can have very compact designs like the BTS. Some example products are here an FAC, so fast access collimator, with which you can collimate either the fast access of a single emitter or of a bar, here shown in the picture. We can ship them, for instance, in gel packs or different kinds with multi-million pieces yearly. You can choose from a standard portfolio beginning from 160 micron to several millimeters, and we can customize solutions for you either in length or coating or customized effective focal length, for instance, for automotive LiDAR. Another example would be an SAC or telescope array for the collimation of slow axis emitters at once. So if you have a bar, each individual emitter would then be collimated with a single piece of glass. You can choose from the standard portfolio here or go for customized solutions. Another example would be our BTS, which consists of an FAC to collimate the fast axis of all emitters and a transformer that twists each individual emitter of a laser bar by 90 degrees. That has the advantage that it's much easier to couple a full bar into a fiber and more, or go for high power free beam lasers. You can choose from our standard portfolio, or go for a customized solution if you would like to have a different coating, or for instance, a different pitch that fits exactly your emitter bar. Please note also our fused silica versions for high power. Another example would be our homogenizers. If you start with a high m² beam, you can use a single homogenizer or a set to create very homogeneous intensity distribution, either square or rectangular, with very high slopes, high homogeneity, or low contrast. For quick prototyping, you can choose from existing designs, like certain pitches or radius combinations, or go for customized solutions. Important, if you choose from the existing designs, you don't have any existing additional cost. If you would prefer a very high angle, well, then the wide angle diffuser is the way to go. We can create a line with homogeneous intensity distribution up to 160 degrees. It is designed in such a way that a single diffuser creates one line, or in combination with a second diffuser, a rectangular intensity distribution. Important to note here is that it's applicable to various laser sources. Just to name a few of the advantages, you can go for very high angles, for instance 160 degrees, far beyond the polymer possibilities. You have the freedom to combine different fields of use, for instance 60 by 45 or 120 by 20 degrees. Then the overall design is based on an ROE, so a refractive optical element approach. So you don't have any zero order problem, so no hotspot in the center to make it eye safe. You have a stable performance in wide temperature range, especially due to the glass material. So beyond the polymer possibilities, you have a steep slope of angular distribution, high damage threshold, and not to forget, if you code it, you can have transmission higher than 99%. This makes it ideal for LiDAR or DMS. So to quickly summarize, we can start and offer a simulation for different designs. We can produce high-quality micro-optics from prototype stage to high volume, bigger than 10 millions a year. And we have quality control for high volume and high size wafers to match reality with simulations. Not to forget to create designs on both sides individually. Thank you very much for your attention. Looking forward to your questions. Please visit our booth and contact our sales team. Thank you.